Hi, my name is Thomas, and this is a short overview on HarnessForge. HarnessForge is a command line tool that automates the creation of verification tasks for industry-scale software projects written in C. In this demo, we will use a Docker image that you can also pull with the command that you see here so that you can follow along. When you enter the container, you will be in the data directory and first have to change to directory HarnessForge. If you do not use the container but downloaded HarnessForge yourself, please first check the installation instructions in the README to set up your system. The bin folder contains the HarnessForge command. In the Docker container, HarnessForge is also added to the path, so you can just run HarnessForge directly. And the HarnessForge directory contains the source code of HarnessForge for inspection and further development. We will use a small example project of a counter that randomly increases a number. So the counter checks the number of increases and the current value starting at 0 for both. And when add_random is called, it gets a random short from a random number generator, checks whether an overflow would occur, and if not, it performs the increase. Now we have a small main method that shows the use of this counter. You can create the project with make. This compiles the source files. And now if you run the counter, you see different inputs and how the counter is used. Okay, let's clean the project again because we will need to build it again with HarnessForge in a moment. Now what we want to do is verify that certain properties about this counter. And for this, we created the formal directory that contains some additional files. First, the counter YAML, which defines verification tasks. So it has a name and some descriptions just for the reader, and then it defines a sequence of tasks. And each task consists of 3 steps. Before target is methods that must be called before the target method. Target itself is the target method, so in our case the add_random method of the counter, and after target is methods that must be called after the target. So before target in our case is some initialization, and the after target is some post conditions, some assertions that we want to check. We have one task that just calls add_random once, and we have one task that uses a special function to call add_random multiple times. So you have access to all of these files. I will not go through them in detail, but just show you how to run HarnessForge. The first thing you do is run the create task method with the configuration file that you want to use. In our case, counter YAML. And then on the first use on a project, you need to create a project config that tells HarnessForge how to assemble all of the files and where to find them. And for that, you use ---- and provide the build command for your project. So when running this, HarnessForge compiles the project with the build command and records the build configuration. Now this config is missing the files we added in the formal directory. So we have to edit it and add these. So here I add formal source, and down here I add some overrides because we do not want to use the original random number generator, but other files. After storing this, it saves the file in project config YAML. So we do not need to do this on every invocation, but just on the first. And then it creates the 2 tasks files for us. So in the output tasks folder, you can find the counter add_random once.i, which is the actual tasks, with a main method that includes all of the targets that you ran. It includes the original C files before preprocessing and slicing. It includes a YAML file, and it includes some statistics about the task generation. So for example, for add_random once, here we get some information about the files that were aggregated, and we see that before slicing lines of code was 605 and after only 85. And then we can, for example, call cbmc on these tasks to check whether our post conditions hold, and we're happy. Of course, HarnessForge does not only work on small projects, but also on real-world projects. So we can, for example, use it on the Intel TDX module to create verification tasks. And I'll use the example that's also available in our paper. And here the project config already exists, so I'm not adding the build command. And as you can see, HarnessForge is computing the relevant sources and will then assemble the verification tasks for us. Because this is a larger project, this takes some more time for the first task, but then HarnessForge uses caching and the other task generations will be faster. Now you can find more information in the tutorial folder, including how to create initialization functions to reduce boilerplate. And thank you for watching.